graphs allow us to visualize a rate of change. In this problem, they're asking us to graph the following. In 2000, there were 125,000 U.S. dairy farms. There has been a sharp decline with a loss of 5,100 dairy farms per year. And they're asking us to find how many farms in 2016. The rate given here is the loss of dairy farms per year, and as a general rule, the quantity listed in the numerator appears on the vertical axis. So we'll put the number of farms on the vertical axis. The value in the denominator of our rate is the quantity that appears on the horizontal axis, which is going to be years. Filling in some values then for this particular problem, we have our axes taken care of. And to graph this, to answer the question as well, we need a couple points. Well, the problem gave us the number of farms in 2000, so we have 1 point. To answer the question and to find another point for the year 2016, we know that 16 years have passed, or the difference between these two. So we're going to take 16 times that rate of decline for the farms and the data that was given in this problem. So 5,100 per year times 16 years results in a decrease of 81,600 farms in that 16-year time period. How many farms that is will be determined by taking the original number in 2000, 125,000 farms, minus the number that have been lost in this 16 years, resulting in a remaining number of farms, 43,400. Plotting these two values then, the year 2000 and the data we found for 2016, we now have a graph showing this trend or decline in the number of dairy farms. Here we have an example for depreciation of color copier. The question is asking what rate is represented by this graph. Well, we have rates of depreciation is what we're dealing with, and again, as that general rule, the numerator value is the vertical axis, which is the value of the copier versus the value in the denominator, which is here found in the horizontal axis. So drop in value per number of years. It's asking us further, at what rate is the value changing? So let's pick two convenient values and see what happens between those two. Well, we have a drop. To get from this 1 point, we're dropping $1,000 over the course of 2 years. If we take that drop in value, which is 1,000 minus the 2,000, a negative, there's our drop, over the course of same order, 4 years to 2 years is 2 years, results in a simplification of a drop or depreciation of $500 per year on average. In this last graph, we have data from a hair salon, and it's asking us what rate can be determined from the graph. So on this graph, we see on the vertical axis we have the number of haircuts completed. Horizontal is the time of day. Vertical is what we're going to put in the numerator for our rate, and the horizontal axis information is our denominator. So we have a rate of number of haircuts per hour. To calculate what that rate is, pick two convenient values and determine those changes from one to the other. So here we have at 1 o'clock in the afternoon, 2 haircuts. And then to go over to this other point, we have done an additional 8 haircuts over the course of 4 hours. If we take those 2 points, we had 10 haircuts at 5 o'clock, 2 haircuts at 1 o'clock, subtracting the haircuts. 10 minus 2 leaves the change of 8 haircuts for our numerator. 5 o'clock minus 1 o'clock is a matter of 4 hours time span, and then simplifying we end up with an average of 2 haircuts per hour.